At 50,000 writes per second, DynamoDB's default eventual consistency returned stale user balances, triggering support tickets and a temporary withdrawal freeze. The fix, enabling strongly consistent reads, doubled costs and halved throughput, exposing the real scaling issue. Let's break down why this happened and how to avoid it. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Amazon Web Services' relational database service DynamoDB. Relational database service provides ACID transactions with strong consistency by default, using traditional SQL databases. DynamoDB offers tunable consistency, but defaults to Eventual, which can cause stale reads under high concurrency. The core tension: relational database service guarantees you always see the latest write, but at the cost of horizontal scaling limits. DynamoDB scales horizontally but may return data that's seconds old. Relational database service uses synchronous replication, so a committed write is immediately visible. DynamoDB replicates asynchronously across AZs, so reads may return stale data. If you need the latest data, you must explicitly request strongly consistent reads, which cost double and may fail if a replica is unreachable. Relational database service requires a fixed schema with defined columns and constraints. DynamoDB has no schema constraints except a partition key. Items in the same table can have different attributes. That flexibility comes at the cost of no automatic referential integrity or joins. Here's a typical relational database service schema with foreign keys and constraints. This enforces relationships at the database level. Relational database service supports full SQL with joins and aggregations. DynamoDB only supports 3 operations: getItem, query, and scan. Every other filter must be applied client-side. That means you must design your access patterns before writing code. This DynamoDB query retrieves all orders for a user by using a composite key. Note that you must know the access pattern upfront. Relational database service scales vertically. You upgrade the instance size. Read-heavy workloads use RED replicas. DynamoDB scales horizontally from day one, but a hot partition key can throttle writes regardless of total capacity. Here's how you define a DynamoDB table with provisioned throughput. Each partition key can handle 3,000 RCU and 1,000 WCU. If you exceed that, DynamoDB splits partitions automatically, but only if your partition key is well distributed. DynamoDB guarantees single-digit millisecond latency for getItem and query at any scale. Relational database service latency varies. A simple PK lookup can be 1-5 ms, but a complex join can be 100 ms or more. Relational database service charges per instance hour, even when idle. DynamoDB charges per request. On-demand is great for variable loads, but can be 10x more expensive for steady traffic. Always run a cost analysis. This CloudFormation snippet sets up DynamoDB autoscaling based on utilization. It targets 70% read capacity utilization to avoid overprovisioning. Here's a practical decision tree. If your data has clear relationships and you need ACID transactions, choose Relational Database Service. If your access patterns are primarily by primary key and you need low latency at any scale, choose DynamoDB. Many production systems use a hybrid approach. This is the same issue we highlighted at the start. Here's exactly why that happened. During a marketing campaign, user balance queries returned stale data because DynamoDB's default eventual consistency was used. 2 reads for the same key could return different values within a second. Financial systems need strong consistency, which DynamoDB offers, but at half the throughput and higher cost. The team didn't enable strongly consistent reads because they didn't understand the trade-off. The fix was to enable DynamoDB's ConsistentRead parameter for all balance queries. This doubled read costs and halved throughput, revealing the underlying scaling issue. They then moved to Relational Database Service PostgreSQL with RED replicas, which provided ACID transactional reads for balance operations and eventual consistency for reporting queries. This is the exact mistake from the incident. By not setting ConsistentRead true, the application used eventual consistency, causing stale balance reads. Always use strongly consistent reads for financial data. A common mistake is putting highly relational data into DynamoDB and trying to simulate joins via multiple API calls. That pattern breaks under load. Each extra read doubles latency and cost. Using a timestamp as partition key causes all writes to go to one partition, leading to throttling. Use a high cardinality attribute like userid to distribute traffic evenly. A single DynamoDB scan on a large table can cost more in consumed RCUs than a month of normal traffic. Always use query with key conditions instead of scan. The article mentions last writer wins, LWW, for DynamoDB global tables, but doesn't explain that LWW can silently drop concurrent updates to different attributes. Use conditional writes or application-level version vectors to merge attribute-level changes, especially for multi-region writes. To prevent duplicate charges or inventory oversell under eventual consistency, use DynamoDB's condition expression with attribute not exists or a version number. This ensures writes only succeed if the item hasn't changed since last read. The article notes relational database service connection limits, but doesn't mention that max connections is tied to instance memory, e.g., DBR5 large defaults to 600. Use relational database service proxy or PG bouncer to pool connections and avoid hitting OS limits under high concurrency. Deploy relational database service proxy to manage thousands of application connections without exhausting database connections. This snippet creates a proxy for an existing relational database service instance with identity and access management authentication. Use these commands to diagnose issues. Check if you're using DynamoDB with eventual consistency when strong consistency is required. Monitor CloudWatch metrics for throttling and cost anomalies. Let's run through some common interview questions. When would you choose DynamoDB over relational database service? Key-based access, known patterns, tolerate eventual consistency, need horizontal scaling. Explain a hot partition key and mitigation. One key gets disproportionate traffic. Use high cardinality key, add random suffix, or write sharding. Trade-offs of strong versus eventual consistency. Strong, 2x RCU, higher latency, latest data. Eventual, cheaper, faster, may return stale data. And a few frequently asked questions. Can I use both relational database service and DynamoDB together? Yes, many production systems use a hybrid approach. Which is faster for simple lookups? DynamoDB, single-digit MS at any scale. Is DynamoDB cheaper than relational database service? Depends on workload. On-demand cheap for low traffic, expensive for sustained high throughput. To recap, relational database service is for relational data with complex queries and strong consistency. DynamoDB is for high-throughput key-based access with predictable latency. The biggest mistake is forcing one database to do everything. Design your access patterns before choosing, and always test with production-scale traffic. Ready to go deeper? Up next, Amazon Web Services Lambda and serverless, then Amazon Web Services Fargate. Serverless containers on Elastic Container Service and Elastic Kubernetes Service, then Amazon Web Services Elastic Kubernetes Service. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.